Alright, let's look at the homework 3.9, problem number 3. Alright, a street light is mounted at the top of a 15-foot tall pole. A man with 6 feet tall walks away from the pole with a speed of 5 feet per second along a straight path. How fast is the tip of his shadow moving when it's 35 feet from the pole? Alright, so let's try that. Alright, so let's draw a picture. Alright, so we have a 15 feet tall pole. So we're gonna draw that. So that's 15 feet. And it's a street light. So it's so straight light here. It's shiny like that. Alright. Then you have street here. Going like that. Alright, and so that's 15 feet tall. So this is 15 feet. Right? And a man 6 foot tall. So here's a man right here. And he's 6 feet tall. Alright, and walks away from the pole at the speed of 5 feet per second. So he's walking this way at the rate of 5 feet per second. Right? Then along a straight path, how fast is the tip of his shadow? So shadow would be, so it's going to be, let's see, so it's going to, so the tip of the shadow should be somewhere around here. So I'm gonna draw a shadow. So shadow should look like something like this, right? So that's his shadow right there. Right? And so the what we want to know is how fast is tip of the shadow. So which is right there. This guy is moving that way. So we want to know how fast there. Alright. Alright. So what we need to do is we need to give variables for changing quantity. So I'm going to give variable. So first, the distance between the pole and the person, a man. So that's going to be x right here. Right. Also, we want to know how fast the tip of the shadow moving. So we want to just measure the distance from the pole and the tip of the shadow. So that's going to be, I'm going to call it y. Actually, I'm going to call it s because it's a shadow. All right. How about that? All right. Then try to set up some kind of equation relating x and s. All right. And first, we know that since the man is walking away from the street light, so at the rate of 5 feet per second, this is the rate of change of x with respect to time. So this is dx over dt. Right? Then what we want to find is the rate of change of s with respect to t. So what we're trying to find is ds over dt. Alright, so let's set up equation. Right, first we're going to look at the big triangle, which is a right triangle. So I'm going to draw that triangle here. So you have a big right triangle. So this is straight light there, and then go straight to the tip of the shadow. Right, so you have a big triangle like that. Right, so that's 15. Right, so this is right angle there. Right, and so this length is s. Right, then we look at this smaller triangles here, right triangle, using the height of this person. So we're gonna have let's see, something like this. So that's going to be 6 feet. Right, and it's also a right triangle. Right, so it looks kind of like that. Right, and this length is actually this length, which is a difference between s and x. So this is going to be just the s minus x. All right, and since this angle corresponds to this angle right here, which is the same angle as here, right? So these two triangles are similar triangles. So these are similar using angle criterion. We have that. All right, so therefore we can use the ratio, right? So we know the ratio between s to 15. So s to 15, right, must be the same as the ratio between s minus x to 6, right? So since I don't like fraction, let's say we're gonna multiply both sides by, how about 30? So that's like a least common multiple of 15 and the 6. So I'm gonna multiply both sides by 30. That way I don't have to look at a fraction. So that would be, let's see, 15 and 30 cancel out, so 2. So 2s is equal to, all right, 6 and 30 cancel out, then 5. So it's going to be 5s, all right, minus 5x. All right. So since we are looking for ds over dt, I'm gonna solve this equation for s. Right. So first thing is I'm gonna just subtract the 5s from both sides. Then you get the negative 3s is equal to negative 5x. Right. Then we can just divide through by negative 3. To get s is equal to 5 over 3 x. All right. Then we can just take the derivative from there. So you can take the derivative of that equation with respect to t, since we are looking for ds over dt, which is equal to, take the derivative of that, which is, let's see, 5/3 is just a constant multiple. And derivative of x with respect to t is dx over dt. Right? So therefore, what you get is 5/3, right? And dx over dt, we've seen that somewhere. Dx over dt shows up right here, right? So which is 5. So we put that here, times 5. So therefore, this is 25 over 3 feet per second. Right? So that's how fast the tip of the shadow is moving. Right? So let's type this guy in. All right, so the answer was 25 over 3. Right? So let's check the answer. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.